Okay, good afternoon again, everyone. So, as I mentioned earlier, today we'll finish this study guide, and then the coverage of the problem set, which will come live on Canvas on Monday, will be until what we'll finish today. So, hanggang dito lang yung coverage ng problem set. And the problem set, again, will go live on Canvas. Pwede nyo siyang i-download or i-access on Monday, 8 a.m. And then ang submission ang deadline ay October 27, right before midnight, 11:59. So you will have 4 items there because hopefully you already submitted the first part, which is problem set 1.1. So sana para nabawasan man lang yung mga gagawin nyo next week. So you'll be left with 4 items, and I estimate that you will need around 1 hour to finish one item. So sa Monday sa lab, wala naman kayong ibang gagawin. Worksheet 6 is canceled. So you can devote your 3 hours in the lab. It's your choice if you want to join your lab instructors pa or you want to just work on the problem set. So, sabihan ko rin sila later. Wala naman silang kailangang i-discuss. So, I'll email them na please give your students the choice to either attend the meeting or not kasi problem set nga to. So, you can do it on your own for that 3 hours of your lab on Monday. Or, kung gusto niyo naman, pwede kayong mag-log in. Tapos, tingnan niyo kung nandun yung lab instructors nyo. Tapos, kung may tanong kayo or meron kayo hindi clear dun sa instructions, pwede niyo silang tanungin. Depende sa kanila kung ano yung extent ng mga tanong na i-entertain nila. But yeah, pabaitan na lang to ng mga lab instructors, right? Then I'll try also to be online on my consultation hours on Monday, 1 to 3 p.m. I have the link in Canvas, and also I included you as members of that consultation team. So meron lang akong meeting sometime around 1 p.m. But right after that, you can also consult with me if you have some questions about it. So I suggest Optimize Monday kasi alam po simula sa Tuesday hanggang sa Wednesday, meron na rin kayong ibang mga klase. So try to finish as much as you can on Monday. Take advantage of your lab instructors and me, of our availability during that time. And make sure to submit it on Wednesday. So siguro hatiin ko sa dalawang submission, I will have problem set 1.2. Isang problem yon, ako yung mag-check. And then problem set 1.3 will be the rest of the items which your lab instructors will grade. So magkahiwala yung submission ng problem set 1.2 at saka 1.3. So you will have 2 PDF files to submit on Wednesday. So lagyan nyo ng konting allowance, huwag buzzer beater na 11:59 p.m. kayo magla-login or 11:58 p.m. kayo magla-login para mag-upload. Baka biglang maputol yung submission or yung internet connection nyo, hindi kayo makapag-submit on time. Okay? The submission will close at 11:59, pero yeah, kung magkakaroon ng konting problema about your connection or your submission tapos hindi na bumalik before midnight, pwedeng i-email nyo na lang sa akin as soon as you can. But ideally, finish everything and upload everything in Canvas before the deadline. Kasi dun din mag-close yung submission sa Canvas. All right? So before we begin with the technical stuff, any concerns about the problem set? Any questions that you have? Okay, wala pa. Siguro ang mga reactions sa problem sets ay sa Wednesday pa. Baka lumabas na yung mga reklamo nyo about the problem set. Okay. But anyway, yeah. But I'm open to your feedback about the problem set. You can tell me if it's too hard or it's too long for the time frame para ma-adjust ko yung mga susunod na problem sets. Kasi medyo nangangapa rin ako. This is my first semester back in UPLB. So hindi ko pa gamay kung gaano kabigat yung pagbibigay ng problem set sa inyo. Okay? All right, so let's have that. Let's talk more about that on Wednesday. But so today, as I've mentioned, we'll have 2 theorems. We'll try to prove 2 results. The first one will deal about combining proof techniques. Kasi meron na tayong ilang methods of proof na alam. So we have the direct proof, especially for actually meron tayong existential proofs. These are for statements that claim the existence of some number satisfying some property or some objects in the domain that satisfies several properties. So I think we have established at least 2 methods, general methods for proof of existence. Number 1, pwedeng by demonstration or by giving an example. Lalo na kung there exists lang naman yung theorem. So, sufficient na proof na magbigay kayo ng isang example. Right? Pero pag for all, tapos may kahalon there exists, you have to really look at what is the meaning of the statement. And then, halimbawa sinabi niyang for all x, there exists a y. So you need to demonstrate what is the y value for that specific arbitrary x. So yun yung isang way pagpuprove ng existential. Kailangan mag-demonstrate kayo or magbigay kayo eksakto or i-construct nyo kung sino yung element na magpapatunay dun sa existence. The other technique for existential results ay gumamit ng mga existing theorems. Like if you want, yung nakita nating examples para ma-prove na may nag-exist na number dun sa closed interval such that the function value of a continuous function is equal to c. Gumamit tayo ng intermediate value theorem. Siguro pwede nyo rin tingnan yung extreme value theorem from your calculus classes na nag-guarantee naman ng existence ng minimizer at maximizer sa isang closed interval, provided that your function is differentiable on the open interval. So, posibleng ganon. Pwede yung gamitin nyo. Hindi kailangan magbigay kayo ng isang specific element. Pwede nyo ipakita na kailangan merong mag-exist. Alright? So, kaya lang, ang kailangan nyo doon tingnan, kailangan reviewin nyo. Dapat alam nyo yung mga existence theorem that you have encountered before. Okay? Okay, so that's for existence. But probably a good portion of the theorems or the statements that you will encounter in Math 101 and also in your journey in your undergraduate course ay mga conditional statements. So they are of the form P implying Q. And at least we have, I think we have encountered 3 ways on how to prove a conditional statement. Una, pwedeng direct proof. When you say a direct proof, you assume P and then use valid arguments or valid argumentation para ipakita na mula kay Q, kaya nating ma-derive si mula kay P, kaya nating ma-derive si Q. So i-assume natin na totoo si P, kailangan mula doon ma-derive natin na totoo si Q. Right? So that's the direct proof. But we have encountered some statements na mahirap mag-start from P lamang at ipakita na si Q ay totoo, right? So in those cases, it might be easier to look at the contrapositive. So we have seen the proof by contraposition. So proof by contraposition, we will not directly prove P implying Q, but we will prove an equivalent statement. Ano yung equivalent statement? Just apply a transposition to P implying Q. Kakaroon ka ng not Q implying P. So ito instead yung gusto nating i-prove. We will assume not Q and then we want to show not P. Kasi minsan mas marami tayo nakukuhang information mula dun sa not Q kesa kay P. Alright? So that's going to be proof by contraposition. And if you will be able to prove this, then P implying Q will follow because P implying Q is equivalent to this guy. Right? And then last time we looked at the third type of proof, which is the indirect proof or proof by contradiction. Contradiction. Right. So proof by contradiction, gusto nating ipakita na imposible na mali yung theorem. And then by the law of excluded middle, kung imposible na mali yung theorem, so dapat totoo yung theorem. Kasi sa math, wala tayong gray areas. So a statement is either true or false and not neither. So ibig sabihin kung hindi siya pwedeng false, so dapat true siya. And usually for the proof of contradiction, we suppose that what we want to prove is false. So inassume natin na not Q. And then from not Q, we want to derive a contradiction or something that is obviously false or contradictory to another statement that we already know to be true. So pag ganun yung nangyari, na-demonstrate natin na hindi posible na mali yung gusto nating i-prove. Okay? Now, these are, I think, the 3 basic ways on how to prove a conditional statement. And if you will notice, walang ni isa sa kanilang tatlo ang nag-assume ng Q. Right? Kung P implying Q yung statement, never tayo nag-assume ng Q. You never assume what is to be proven for the sake of proving itself. So para magiging circular, hindi nga circular reasoning eh. Parang flatly wrong. Kasi gusto mo ipakita si Q, tapos i-assume mo si Q, that's not fair, right? And that's illogical. So maraming mga ganyan ngayon. So ingat sa pagbabasa ng Facebook posts or TikTok videos. So kalat sila ngayon. So hopefully with the training that you got, alam niyo na mag-spot ng fallacies, all right? So yeah. So today we'll try to we'll look at some examples wherein pwede palang mag-combine itong mga methods of proof na alam na natin in order to prove a certain statement. So ang isang proof hindi dapat purely direct proof lang or puro contrapositive lang or purely contradiction lang. In the middle of the proof, we might need to claim to prove another claim or a statement that was not previously proven before, pero kailangan natin sila para mag-move on dun sa proof natin. So parang meron tayong sub-proof dun sa loob ng bigger proof. So parang naka-nest. Dun sa loob ng proof, meron pa tayong isang mini-proof. And yung proof ng mini-statement ay hindi necessarily kaparehas ng method of proof na gagamitin nyo dun sa bigger o dun sa parent theorem. So they will be independent of each other. So you choose the method of proof according to the necessity or yung convenience nyo. Kung ano yung mas madali para sa inyo na gamitin. Right? So to illustrate this, let's consider example 37. And this says that we want to prove that every rational number can be expressed as the product of two irrational numbers. So kapag meron daw tayong rational number, kaya natin siyang isulat as a product of two irrational numbers. So basically, this theorem is somewhat an existential statement because here we want to prove na may nag-exist na factorization ng isang rational number into two irrational numbers. So in other words, you can think of it as showing that for all rational number Q, there exists A and B hindi pala A and B. There exists, sige, pwedeng A and B nga, pero si A and B are parehong irrationals such that Q is the product of A and B. So parang ito yung gusto nating ipakita. Bigyan man tayo ng kahit anong rational number Q, lagi nating mafa-factor si Q as a product of two irrational numbers. So sort of this is an existential statement. So posible sigurong atakihin natin to by giving an example. So when I say giving an example, I will consider an arbitrary Q and I will give a sample factorization of Q into two irrational numbers A and B. Okay, that's how the proof will go. So proof, again, the claim is for all rational numbers. So kailangan mag-consider ako ng isang arbitrary rational number. So I will take Q to be a rational number. Okay. Then we want to show that merong factorization si Q. All right. Now, can somebody suggest a factorization for Q in terms of two irrational factors? Kasi yung gusto natin ipakita, tama, existence ng irrational factors. So, can you give me a guess, an educated guess? Ano kaya yung posibleng factorization Q into two irrational numbers? Siguro hindi no. Then siguro note that Q can be written as what? Can anybody give me a factorization of Q as two irrational numbers? Oh, while you're thinking, medyo may correction pala dapat dito. Prove that every non-zero real number. Doon ko lang din napansin nung nag-lecture na ako kahapon. Dapat non-zero yung rational number. Kasi, bakit sa tingin nyo? Kailangan ko idagdag yung pagiging non-zero. Anong problema kay zero? Si zero ay rational. Pero bakit kailangan ko siyang i-exempt dun sa theorem? Ayan, dalawa na yung tanong ko. May side quest, tapos may main quest kayo. Any volunteer? For either question? Hello guys, nandiyan pa ba kayo? Thumbs up nga kung nandiyan kayo. Kasi kakaiba, parang dati unahan kayo na sa pag-volunteer. Ngayon sana yung magandang may kape ako dito sa gilid para habang nag-iisip kayo, ay pwede ako magkape. Pero hindi ako nakapagtimpla, nalimutan ko. So, any idea? Question number 1, ano kaya yung factorization para kay Q in terms of 2 irrational? Or side question, bakit in-exempt ko si 0? Bakit hindi covered ng theorem si 0? Oh, yes, Neil?
Sir, pwede po siguro factorization yung ano po, A times Q over A po, sir. Tapos in-exempt po yung 0, sir, since pag dun sa Q over A po, sir, pag nag-0 po si Q, sir, ano po, magiging rational po yung second factor po.
Okay, thank you, Neil. Sinolo na ni Neil yung dalawang questions, but that's fine. Thank you, Neil. Yeah, that's right. In-exempt ko si 0 kasi remember kapag meron tayong dalawang number na pag pinag-multiply natin na equal kay 0, alam natin dahil nasa field of real numbers tayo, kapag meron tayong pinag-multiply, ang sagot ay 0, either A is 0 or B is equal to 0, meaning at least one of the factors is surely equal to 0, right? Pag yung isa sa kanilang dalawa ay nag-0, mali na yung theorem. Kasi si 0 ay rational. So si 0 hindi natin kayang ma-factor as a product of two irrational numbers. Because the only time we can get a product equal to 0 is that if one of the factors is equal to 0. All right? So kaya exemption si 0 dun sa theorem. Okay? Now, tama yung suggestion ni Neil. I think Neil is saying that tama ba? Si A dapat ay irrational, right? So, can you give me a specific A? Anybody else? Tama, ito yung form ng factorization. Pero ang problema kasi wala tayong characterization ngayon sa mga irrational numbers. Meron ba kayong kakilalang irrational number? Or at least na-prove natin to be irrational? Yes, Trisha?
Yung square root of 2 po.
Okay, thank you, Trisha. Yeah, si square root of 2. Gamitin natin siya kasi si square root of 2 na-prove na natin to be irrational. All right? So, okay, so alam na natin yung unang factor, si square root of 2 ay irrational by one of the previous theorems that we have seen. So, maybe I could write that down here. We know that square root of 2 is irrational. Also, now the problem is, are we sure that Q over square root of 2 is irrational? Yun yung problema. Si Q ay rational number. Pag nag-divide ba tayo ng rational number by an irrational number, are we sure that the quotient will be irrational? Sure ba tayo na ito ay irrational? Actually, we don't have any proof of that so far. So we don't have any choice but within this proof, okay? Kasi ang usapan, ipuprove lang naman natin na kayang i-factor si Q as a product of two irrationals. Tapos si Neil at saka si Trisha, nagbigay sila ng factorization. Square root of 2 times Q over square root of 2. Well, it's right that when you multiply these two factors, I'll get Q back. Pero ang problema, sure lang ako na si square root of 2 ay irrational. Hindi ko sure kung si Q over square root of 2 ay irrational din. We don't have any theorem yet to cite na totoo ito. So we have no choice, but inside this proof, we'll write another proof. Now, a proof for this claim. So we claim that Q over square root of 2 is irrational. Okay? Kailangan nating ipakita na siya ay irrational. Right? Now, any suggestion? Anong method of proof kaya yung magandang gamitin sa pagpapakita ng irrationality ni Q over square root of 2? Kasi kung dadaan tayo sa definition ng pagiging irrational, the way to show that this would be is an irrational number directly is, yes, Ila?
By contradiction po, so.
Okay, thank you, Ila. Yeah, that's right. Yeah, kasi mahirap ipakita na hindi siya kayang isulat as a ratio of two integers. And Eli is right. Perhaps we can attack this mini proof by a proof by contradiction. And for that, we will suppose, for the sake of contradiction, that q over square root of 2 is rational. Okay? So ganito yung proof by contradiction. Kunwari, mali yung claim natin. Then it will follow that what? That q is equal to or siguro I can say first that note that note, sabihin natin, recall that q was assumed to be rational, right? Mula dun sa taas, si q ay inassume natin to be rational. That is not equal to 0. So q less set containing 0. So siya yung mga non-zero rational numbers. Then there exists integers A and B that are both non-zero. Such that q is equal to a over b. Again, let's review what I'm doing here. Medyo siguro nagkaroon ng konting leap dun sa proof. Tama si Ila, by contradiction yung gagawin ko. So i-suppose ko na si q over square root of 2 ay rational. Pero alam ko before na si q ay non-zero rational number. Siguro ay sulat ko pala to ng ganito. Hindi pa pala natin na-define yung set operations. Sorry about that. Sulat ko na lang siya ng ganito. Yeah. Q is a non-zero rational number. Then, dahil rational number siya by assumption, so may nag-exist na integers A and B such that Q can be written as A over B, right? Definition ng pagiging rational ni Q. Pero si Q ay non-zero, so sure tayo yung numerator hindi pwedeng mag-zero. Tapos by definition of division, hindi rin pwedeng mag-zero yung denominator, right? So I'm sure now that A and B are both non-zero. Okay? Now we have here an alternative factorization, another alternative form for Q, right? So again, ito si Q, A over B. Pero from above, we suppose Q is equal to this guy, which is actually true, right? Totoo naman na si Q ay equals to square root of 2 times Q over square root of 2. All right? So this means I can equate A over B to this expression for Q. Okay, so let's na lang siya dito, square root of 2 times q over square root of 2. Siguro hindi pala maganda to. Sorry, burahin ko to. Masyadong maging hahaba yung proof pag yun ang ginamit ko. Pero siguro, kasi nga, mini proof yung ginagamit ko. So as much as possible, I want to limit the things that I will use dito sa assumption na to, right? Or dito sa supposition natin for the sake of contradiction, right? But what do we know? Dito ko na pala gagamitin itong supposition. Inassume natin for the sake of contradiction that q over square root of 2 is irrational, right? Is rational. So there will exist integers c and d such that q over square root of 2 will be equal to c over d. Right? Here, d not being equal to 0. Actually, pwede rin natin dito sabihin na si c ay hindi rin equal kay 0. Kasi pag si c ay naging equal kay 0, the right-hand side will be equal to 0, but the left-hand side is the quotient of two integers. Si q ay non-zero, so yung right-hand side hindi pwedeng mag-0. Tama ba yun? Tama, no? Si c hindi pwedeng mag-0 kasi mag-0 to. So magkakaroon tayo ng q over square root of 2 equals 0. Then multiply both sides by square root of 2, we'll get q equals 0. So si c hindi pwedeng mag-0. Okay? I think this is fine. Inassume kasi natin na rational to. Dahil rational siya, pwede siyang masulat as a ratio of two integers, the denominator of which is not equal to 0, right? But here, what do we have? Okay, so here we have, from here I can perform some manipulations. I can multiply both sides by square root of 2 times d. So that will have qd equals square root of 2 times c, right? Cross multiplication now, or we multiply both sides of the equation by square root of 2 times d. And then I'll divide both sides by c. Okay, which is fine because we know that c is non-zero. So dividing both sides of an equation by a non-zero number is valid. All right. So what do we have right now? We have an expression for square root of 2. Baliktarin ko lang siguro yung equation. Okay. Remember that we have another expression for for q. We said that q, being a rational number, can be written as a over b. I will plug in this value of a over b for the q here, and I will have ad over c, where ad is another integer, all right? So si qd over c, pwede masulat na ad over c, pero si a at saka si d parehas integers, their product will also be an integer. So essentially what we have here is square root of 2 being expressed as a ratio of two integers, namely ad and c, which is a contradiction, right? This is absurd kasi alam natin si square root of 2 ay irrational, and yet kung tatanggapin natin na si q over square root of 2 ay rational din, so dapat si root 2 ay magiging rational din pala. But that is impossible because we have provided a proof of the irrationality of square root of 2, right? So therefore here, we don't have any choice but to accept the claim that that q over square root of 2 is irrational. All right? Dahil irrational siya, so that means we have provided a factorization of q. So then any rational number is the product, or every non-zero nga pala, is the product of two irrational numbers. And then end of proof. Because we have provided a factorization, square root of 2 times q over square root of 2, and we are sure that q over square root of 2 is irrational. Okay? So is that proof clear? So nakita nyo ngayon yung pag-combine ng mga methods of proof. Una, existence, nag-construct tayo. Pwede nyo isipin, proof by construction, nag-construct tayo ng factorization. Kaya lang, in the middle of that proof, we have encountered a problem. Hindi ko pa pala sure na si q over square root of 2 ay irrational. So we need to prove that indeed that is irrational para walang mahanap na butas dun sa proof natin. And in order to prove that, we use contradiction. All right? Okay, so if there are no questions there, so we can continue. And here we will be proving biconditional statements. Okay. Yes, John Raphael.
Sir, saan po napunta yung B po?
Yung
B. Kasi po, Q times D over C. Saan po napunta
Ano?
yung B?
Yeah, thank you, John Raphael. Yeah, nakalimutan ko yung B. Tama, si Q nga pala yung papalitan ko ng A over B. Bigla siya nawala. Ayun, nandun siya. B over C dapat. AD over BC. Thank you, JR. Yeah. So kailangan ko rin sabihin dito na integers si AD at saka si BC. Okay. Parehas silang integers. So ratio pa rin ng dalawang integers si square root of 2. If i-accept natin yung supposition na si q over square root of 2 ay rational. Okay? Thank you for that. Counted yan na sa recitation mo, JR. So paki-note later.
Okay po, salamat.
All right. Now going back, This last example deals with a biconditional statement. Recall, pag sinabi nating biconditional statement, siya yung P if and only if Q, or in symbols P, double-headed arrow, and Q. And I guess, I hope that you remember from the rules of equivalence na yung P if and only if Q ay equivalent sa statement na P implying Q and Q implying P, right? So kaya double-headed arrow yung gamit na symbol. Kasi from P, tumakay ka sa arrow na to, makakarating ka kay Q. Tapos kung nagsimula ka naman kay Q, gamitin mo tong arrow na to, yung left-headed arrow, makakabalik ka kay P. So that means P implies Q, and the converse, Q implying P, is also true. Nabanggit yata natin last time na ang converse ay hindi laging totoo. Alright? Ang contrapositive laging totoo or laging equivalent sa P implying Q. Pero kung totoo si P implying Q, hindi necessarily totoo yung converse na Q implying P. Pero if the statement is presented as a biconditional statement, that means the forward implication and its converse are both true. Kaya medyo mahirap mag-prove ng if and only if statement kasi these are basically two statements in disguise and they will require independent proofs. On the first part of your proof, we need to prove P implying Q, meaning I'll start with P, I want to show that Q follows. Pero natutunan natin pag prove ng P implying Q, pwede tayong gumamit ng tatlong technique. Pwedeng direct, assume P, then show Q. Pwedeng by contraposition, assume not Q, then show not P. Or pwede rin naman contradiction, assume not Q and P, tapos maghanap ng contradiction. Alright? Tapos, pag tapos ka na dun sa proof ng P implying Q, kalahati pa lang yon ng proof ng biconditional. So, kailangan mo pang i-prove yung Q implying P. And for Q implying P, again, you have three options because the proof of P implying Q is independent, or most of the times is independent of the proof of Q implying P. Hindi ibig sabihin na nag-direct proof ka sa P implying Q tas gumamit ka ng, say, Theorem A na na-prove before. Ganun din yung magiging atake dun sa proof ng Q implying P. Pwede kang gumamit ng ibang theorem, pwede kang gumamit ng ibang method for it because you can treat them as two separate theorems just lumped together. Okay? That's how powerful if and only if statements are. And actually, if and only if statements are actually a statement that P is equivalent to Q. Na kasi yung P mangyayari kapag si Q ay nangyari and vice versa. Sometimes an if and only if statement is also said a necessary and sufficient condition because in this case, P is a necessary and sufficient condition for Q. Siya ay necessary kasi kapag si Q ay nangyari, necessary na mangyari si P. So ito yung necessity. Si P ay necessary for Q. Right? So pag nangyari si Q, necessary na mangyari si P. Right? And then it is also a sufficient condition for Q. Pag nangyari si P, sufficient na yon para masabi natin na magpa-follow si Q. Kaya ang tawag dito usually ay the necessary part or the necessity part, and this is the sufficiency part para ma-prove yung P if and only if Q, which often is also said to be P is a necessary and sufficient condition for Q. And you will see na hindi lang to sa theorems because the power of biconditional statements makikita rin natin sa definitions. Kasi pag sinabi nating definition, nagka-characterize tayo ng isang term. Kung kailan nagiging yung isang object ay matatawag na natin under that term. So meron tayong necessary and sufficient condition. Kaya yung mga definition, kahit hindi sila nasusulat na if and only if statements, they are actually assumed to be if and only if statements. Because we are giving a necessary and sufficient condition so that a certain element or a certain object can be called the term to be defined. So ganun yung idea ng definitions. So kung meron kang theorem that is phrased as a biconditional statement, then that could be a substitute definition for the term involved in the statement. And probably I'll illustrate that later when we go to set theory because doon makakita tayo ng mga equivalent or mga alternative definitions. But for now, our business is to prove biconditional statements. And as I've mentioned, nothing new, nothing is new, but there's no much new with this. Kasi ang gagawin lang naman natin, first step, hatiin siya sa dalawang cases. Tapos, i-prove natin sila na magkahiwalay. Okay? Unless, puro rules of equivalences yung gagamitin nyo. Pwede nyo ma-prove yung P if and only if Q ng isang bigayan lamang. Pero ang requirement ton dapat rules of equivalence lang yung gagamitin nyo. Kapag gumamit ka ng rules of inference, kahit isang beses lang, o kaya gumamit ka ng isang theorem na one way lang, na isang implication lang, then hindi mo na siya magagamit as a one proof fits both conditional statements. Kailangan mo na siyang hatiin into two cases. Okay? And then usually, mas madaling i-prove yung isang part kesa dun sa isa. Alright? So, kaya talagang hindi same yung difficulty at saka yung complexity ng mga proofs sa isa't isa. So, we need to analyze them on their own. Okay? To illustrate, let's look at example 38. Okay? So, here we want to prove that if y is a real number, okay, that's the generic assumption, then there exists a real number x such that this equation is true if and only if y is not equal to 2. All right? So this is an if and only if statement. This is our P. There exists a real number x such that this guy, then if that is true, then y is not equal to 2. And then the converse, sabi nung example, ay totoo rin. Na kapag ka si y ay hindi equal kay 2, then magfa-follow na may nag-exist na real number x such that this equation is true. Okay? So let's try to prove it. Let's start with the sufficiency or sufficient condition. So proof. Usually, pag nagpo-prove kayo ng biconditional, I will appreciate it if you will label the two parts of your proof by the arrow na gagamitin niya para alam ko kung ano yung direction na gusto niyo munang i-prove. Kasi nga dalawang parts yung proof dito. So here I'll start with the forward statement first, yung sufficiency condition, that P is sufficient for Q. So for this, you start your proof by stating ano yung ina-assume nyo. So dahil forward yung pinuprove ko, i-assume ko muna si P na may nag-exist na real number x such that that is true. Possibly here, bago ko pala simulan, banggitin ko muna yung general assumption. General assumption ko ay y is a real number. So I will take a real number y here, the beginning, and then after kung ma-state yun, hatiin ko na yung proof sa dalawa. I begin with the forward. I will assume that there exists a real number x such that this equation is true. 2x minus 1 over x minus 3 equals y. Let's call it equation 1. Okay? And then we want to show, pwede nyo ring isulat kung ano yung gusto nyo ipakita para guided kayo dun sa ginagawa nyo. So, inassume ko to, gusto kong ipakita na totoo si Q, that y is not equal to 2. Okay? Kaya lang, kung si y ay hindi equal kay 2, ibig sabihin parang mahirap namang mag-work kasi gusto kong ipakita si y ay hindi equal kay 2. So, ano pwede kong sabihin kay y? So, essentially, y can be any number aside from 2. Yun yung gusto nating ipakita. So, it might be difficult to just look at the assumption and from here derive that y is not equal to 2. That's why I will attack it by a proof by contradiction. So, I will suppose, for the sake of contradiction, that y is equal to 2. Mas maganda itong assumption na to, itong supposition na to, kasi then I can use equation 1, okay, and use there y equals 2, substitute ko siya doon, alright, which is fine kasi inassume ko for the sake of contradiction na mali yung y not equal to 2. So dahil inassume natin for the sake of contradiction, dapat si y daw ay equal kay 2. So I can use 2 into this equation. Equal to kay 2, right? From the supposition and the assumption 1 or equation 1. And then from here, I want to get a contradiction, right? So what I can do first is to multiply both sides kasi parang yun yung natural gawin. pag nakakita kayo ng fraction sa equation, parang instinct na mag-cross multiply ng denominator. So here I'll have a 2x minus 1 equals 2 times x minus 3. This will give us 2x minus 1 equals 2x minus 6. And here, I'll say there's a contradiction. What is the contradiction here? Anyone? Yes, Prince. Ano yung contradiction? Okay, Prince says by simplification, I think he meant subtracting 2x from both sides. We'll get -1 equals -6, which is obviously false, right? Hindi pwedeng maging equal si -1 kay -6. Because if we will insist na mali yung theorem, ibig sabihin si y ay equal kay 2, dapat tanggapin din natin at the same time na ang -1 ay equal kay -6. Pero sa field of real numbers, hindi naman equal si -1 kay -6. Guguho yung foundation ng real number system natin. Pag nagpunta kayo sa Math 111, makakita kayo ng ibang structures kung saan equal si -1 kay -6. Pero sa totoong buhay, mali pala, totoong buhay, sa field ng real numbers, ang -1 hindi naman equal kay -6. So therefore, we will say that the supposition is false, so therefore y must not be equal to -2. And here we're done with the first half of the proof. We have proven that P is sufficient to conclude Q. Now, off to the second half of the proof, we will prove the backward arrow or the backward implication, or what we call the necessary condition. We will show that P is necessary for Q. Na pag si Q ay nangyari, dapat mangyayari rin si P. Okay? Now for here, we will assume that y is not equal to -2. Doon tayo nag-start sa Q. And then we want to show that there exists an x in R such that 2x minus 1 over 2x minus 3 is equal to y. Ito yung gusto nating ipakita. Okay? Ngayon, itong problem natin ay existence ng isang x given si y in the first place. Pero assumption na natin si y ay hindi equal kay -2. Ang challenge, sa kahit anong y na hindi equal kay -2, kaya nyo bang magbigay ng x na totoo itong equation na to? So anyone, what could be the nice value for x? Medyo mahirap pala, no? So kung mahirap siyang isolve, so wag mahiyang mag-preliminary analysis. So pwede siguro on the side, you'll do a preliminary analysis. Pwede nyo siyang isama sa submission nyo, pero hindi required. Pwede hindi nyo na isama yung PA. So ang gusto natin gawin is to find a real number x such that 2x minus 1 over 2x minus 3 equals y. Dahil preliminary analysis naman to, pwede ako mag-work backwards. So I can multiply both sides by, we're solving for x, no? So pwede ako mag-multiply both sides ng 2x minus 3. Isosolve ko lang si x in this equation. So equal kay 2xy minus 3y. Tapos lahat ng may x gusto kong malagay sa kaliwa at lahat ng walang x gusto kong malagay sa kanan. So I'll have 2x minus 2xy equals 1 minus 3y. The reason I want all x's or all those with factor x to be on the left side para makapag-factor ako. So I can factor x from the left side. I'll get what? I'll get 2 minus 2y equals 1 minus 3y. And then what will happen if, or tama ba yung solution to? Nakita ko kasi yung sagot sa answer key. Ang x daw ay equals sa 2 minus y. So, saan ako nagkamali? Tama ba yung algebra ko? 2x minus 1 over 2x minus 3, 2xy minus 3y. So 2x minus 2xy equals 1 minus 3y. It looks like x should be 1 minus 3y over 2 minus 2y. Or saan yung mali ko? Did you see something wrong, guys? Feeling ko dapat 2 minus y. Saan ako nagkaroon ng mali? Okay. Mali yung assumption ko. Gusto pala natin ay 2x minus 1 over x minus 3 lamang. Mali yung given ko sa problem. So, dapat ito ay xy lang. So, ito ay minus xy lamang. So, ito ay y lamang. So, ito ay 2 minus y. Okay? So, in our preliminary analysis, we found that for this equation to be true, posibleng piliin natin si x to be 1 minus 3y over 2 minus y. And is it valid? Wala ba tayong magiging problema sa x value na to? The x value that we are proposing is a fraction. At ang isa sa mga nakakapag-disqualify sa fractions ay pag yung denominator ay equal kay 0. But the denominator is 2 minus y, and that will be 0 if and only if y is equal to 2. But we already mentioned that part of our assumptions is that y is not equal to negative 2. So that means this is a valid choice for x kasi well-defined yung fraction na yan. Okay? So that's what you see here in the rest of the proof. So we can take x to be 1 minus 3y over 2 minus y. Galing dun sa preliminary analysis. And we just want to prove that this value of x will make 2x minus 1 over x minus 3 equal to y. At sabi natin, pag nagpo-prove tayo ng isang equation, start ka lang sa isang side at ipakita mo na magpa-follow yung kabilang side. So in this particular equation, so to prove this equation, I will start with the left-hand side. Copying ko siya dyan. Kasi pakita ko na mula rito, makakarating ako kay y. So I have proposed a value for x. Then let's use that here. Plug in that value for x, which we know to be a real number kasi yung denominator naman niya is never magse-zero. So plug in ko siya sa x dito, plug in ko siya sa x dito. Demonstrate your algebra skills. Masisimplify siya until equal siya kay y. Okay? So therefore, kahit ano pang real number y yan na hindi equal kay 2, lagi kang may makikitang x na ang 2x minus 1 over x minus 3 ay equal kay y. Okay? And that proves the necessary condition or the necessity, right? We have proven that Q implies P, and earlier we have proven that P implies Q. So therefore, we can say that we have proven the conditional statement. Napakita na natin na there exists an x such that 2x minus 1 over x minus 3 equals y if and only if y is not equal to 2. Okay? So ganun yung proof proof ng isang biconditional statement. Dalawa lagi siyang parts. And again, most of the times, these two parts are to be treated independently unless sa mga special cases na kaya niyong i-prove using only rules of equivalences. All right? Okay, so I think that's it. And that's the end of this particular study guide. Do you have any questions, guys? Okay, first time matatapos ako ng on time, 6:20. Any questions, guys, or any comments, concerns? Yes, Tricia?
Doon po sa last example, pwede pong yung proof niya po ay magbibigay lang ng value for x or kailangan po arbitrary?
Oh, good question, Tricia. Dapat arbitrary. Kasi kung babalikan niyo yung statement, may pagka-universal yung statement nung sinimbolize ko siya. We want to show that this is true. This if and only if statement is true for any real number y. So dapat sa bawat y, dun sa second part ng proof, dapat sa kahit anong real number y, makapagbigay dapat tayo ng value ni x. And that value of x should hold for the specific given y. Kasi universal siya kay y, existential siya kay x. Dahil may nauna tayong universal, dapat sa kahit anong ibigay na y, dapat may mabigay tayo na x. Unfortunately, walang x na magpapatotoo dun sa equation sa kahit anong y. Walang universal x na mag-work sa lahat ng y. Kasi nakita natin sa ating preliminary analysis, yung value ni x nakadepende dun sa given y at the beginning. So kung posible na na-solve nyo dito, halimbawa ay x equals 4 at mag-hold siya sa lahat ng y, then okay na, nasabihin nyo x equals 4 will work for every y. Pero unfortunately, ang na-solve natin na x mula dun sa PA ay nakadepende dun sa given value ni y. And that is perfectly fine because si y ay given sa start ng problem. Si y ay given to be a real number not equal to not equal to 2. So ibig sabihin, depende dun sa ibibigay na y, yung mabibigay natin na x. Pero in the end, what we have shown is that tapunan nyo ako ng kahit anong y, basta yung y ay hindi equal kay 2, lagi ako makakapagbigay ng value ni x. At yung value ni x na kailangan kong ilagay dun sa proof, it should be generic. So equal siya kay 1 minus 3y over 2 minus 1. Okay, Tricia?
Okay po, thank you.
All right, other concerns or questions? Okay, kung wala na, then let's call it a day. So for those who recited, please put down a comment sa meeting chat natin. And then, yeah, and I hope you enjoyed the rest of the day and also the weekend as well. Though mukhang marami pala kayong kailangan tapusin ng weekend with your other subjects. And we also have our problem set coming up. So yeah, but use your weekends wisely. Kung kailangan nyo talaga mag-work or kung kailangan nyo muna mag-relax para sa next week, kindly do so. Okay lang yan kasi week after next naman ay reading break na, so you will have more time to relax. And yeah, let's see each other again on Wednesday. Bye everyone.